In this video, I'm going to do sort of a deep dive on combustion reactions. So a combustion reaction is when some sort of hydrocarbon, which may or may not contain an oxygen, making it an alcohol, reacts with oxygen gas to produce carbon dioxide and water. So these are the hydrocarbons on the left and the alcohols on the right, where we see each time we're just adding another carbon with its associated hydrogens to it. And so we'll first look at the hydrocarbons. So let's try to balance the reaction for the combustion of methane. In this one, we have one carbon in the reactants, one in the products. So the next thing we want to look at is the hydrogens. We have 4 in the reactants, 2 in the products. So let's put a 2 in front of it. That gives us the 2 times 2 hydrogens. So that's 4 in the products and 4 in the reactants. But in doing that, we also end up with 4 oxygens in the products. We want to try to balance that. We should put a 2 in front of this. And the reason we have to do that is because we have 4 oxygens. We need to divide it by 2 since it's O2, and that gives us 2 O2. And so that would make this our balanced chemical equation for the combustion of methane. Next, we will look at the combustion of ethane. So this is just adding another carbon and its associated hydrogens. Again, the first thing I like to do is try to balance the carbons. We have 2 in the reactants right now, so let's give us 2 in the products. And then we also want to balance the number of hydrogens. We have 6 in the reactants, so we're going to want 6 in the products. But now we see we have 7 oxygens in the products. And this has to be an even number because it has to be divisible by 2, which means that it has to be even. So we can't use 7 oxygens in the products. So what we can do is increment this up by 1. So now we have 2 ethanes rather than 1, and now we can try doing this again. I'm going to start by balancing the carbons. We have 4 in the reactants, so let's put a 4 in front of the carbon dioxide here in the products. And then we want to do the hydrogens. We have 2 times 6 is 12 in the reactants, so we have to get 12 in the products as well. So 6 times 2 gives us the 12. This gives us 14 oxygens total in the products, so we would have to do 7 right here because 14 oxygens divided by 2 gives us 7. So that gives us our 7O2 in the reactants. That would make this our balanced chemical equation for the combustion of ethane. Next, let's try the combustion of propane. So again, we're just adding another carbon onto it. So we have 3 carbons in the reactants. Let's get 3 in the products. And we have 8 hydrogens in the reactants. So let's get 8 in the products. And so 10 oxygens in the products. So we would have to put a 5 in front of the O2 because 10 oxygens divided by 2 is 5O2. And so that would make this our balanced chemical equation for the combustion of propane. Now let's do this again, but for butane. So again, just one more carbon with their associated hydrogens. And so let's try balancing the carbons first. Put a 4 in front of the CO2. Let's try then balancing the hydrogens. A 5 in front of the H2O. This gives us 13 oxygens over here. Again, we can't have 13. It has to be an even number. So we'll increment this up by +1. Then we try balancing the carbons. We try balancing the hydrogens. And so now we end up with 26 oxygens. That's something we can work with because it's an even number, so we get 13 O2 in the reactants. And so that means that this is our balanced chemical equation for the combustion of butane. If we look at the first few examples of the combustion for the hydrocarbons, we see this was our methane, our ethane, our propane, our butane, our pentane, our hexane, our heptane, our octane. And the thing to notice is that we have a 2 in front every time we have an even number of carbons. And we can generalize this a bit further. So when the number of carbons in the hydrocarbon is odd, the number in front of the hydrocarbon is 1. When the number of carbons in the hydrocarbon is even, the number in front of the hydrocarbon is 2. And when the hydrocarbon is odd, the number in front of the carbon dioxide is equal to the number of carbons in the hydrocarbon. When the hydrocarbon has an even number of carbons, the number in front of the carbon dioxide is equal to twice the number of carbons in the hydrocarbon. And we can see that that would just fall out of the fact that we are multiplying by 2 for the hydrocarbon. And when the carbons in the hydrocarbon is odd, the number in front of water is plus 1 more than the number in front of the carbon dioxide. But when the number of carbons in the hydrocarbon is even, the number in front of water is plus 2 more than the number in front of the carbon dioxide. And so in general, when we are doing combustion of these hydrocarbons, if the number of carbons for the hydrocarbon here is odd, then we have a number in front of the carbon dioxide equal to the number of carbons, and the number in front of the water is plus 1 more than that. When the number of carbons in the hydrocarbon is even, then the number in front of the carbon dioxide is twice the number of carbons in the hydrocarbon, and the number in front of the water is plus 2 more than that. And for the more mathematically inclined, you can use this general formula right here, where X is the number of carbons and Y is the number of hydrogens. And we see that M here is going to either be 1 or 2, and it has to be such that Y minus X minus M is always an even number, or that X divided by M is a whole number, not a decimal or fraction of some kind. We can also use the fact that because for hydrocarbons, the Y, the number of hydrogens, is equal to 2x plus 2, we can also use this right here, where this is all in terms of just M and X. And we can see where this comes from by looking at the numbers here. So the number of carbons is odd there on the left, and even on the right. And so if we look at this and kind of extrapolate, we see that this comes up to 3x plus 1 over 2 for the number of oxygens when the number of carbons is odd, and x for the number of carbon dioxides, and x plus 1 for the number of waters. When the number of carbons is even, we get to 3x plus 1, 2x, and 2x plus 2, where we see that these are all just twice the amount for when the number of carbons is odd. And now let's look at this for alcohols. So the alcohols are the things that have the OH group on it. And if we look at the first few examples for this, methanol, we have this, then ethanol, then propanol, then butanol, then pentanol, then hexanol, then heptanol, then octanol. And so now we see that it's actually the opposite of what we had for the hydrocarbons. When the number of carbons is odd, now we have the 2 in front of it, rather than having it be for the even. And so in general, what we see is that when the number of carbons in the hydrocarbon is odd, the number in front of the alcohol is 2, and when it's even, the number in front of the alcohol is 1. When the number of carbons is odd, the number in front of the carbon dioxide is equal to twice the number of carbons in the hydrocarbon, and when it is even, the number in front of the carbon dioxide is equal to the number of carbons in the hydrocarbon. So this is just flipped from what we had for the regular hydrocarbons. And when the number of carbons in the hydrocarbon is odd, the number in front of water is plus 2 more than the number in front of carbon dioxide. And when the number of carbons is even, the number in front of water is plus 1 more than the number in front of carbon dioxide. And again, we can use the general formula for this, and this would be in terms of X, Y, and M, but we see that we can also do this just in terms of M and X as well. And again, this will fall out from this if we just look at the numbers for this. So we just keep going down like this. We extrapolate to what we would have here. And when the number of carbons is odd, we have 3x for the number of oxygens, 2x for the number of carbon dioxides, and 2x plus 1 for the number of waters. Then when the carbons is even, we have 3x over 2 for the number of oxygens, x for the number of carbon dioxides, and x plus 1 for the number of waters. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.